things they are used to doing with computers. So we actually have a long list of all these use cases, and we are working hard to make sure it works seamlessly for users. Let me walk through a couple examples. Most people plug in their cameras, right? They may plug in a USB drive. And so what happens if you plug in a USB drive? You can imagine, this is a rough concept, but you can imagine Chrome opens a tab and shows you what's in the content of a camera or a USB drive. And you can see the files that are on the machine. It turns out in this USB drive there are Excel files. We don't have Microsoft Excel on this machine. So what happens if you click an Excel file? Let's give it a shot. It turns out Microsoft Office launched a killer app for Chrome OS. They've been working very, very hard to do this. The point here is Chrome OS does not have a proprietary app framework. It's a completely open app framework. It's the web. So anybody who puts up a URL, anybody who writes an application that works on the web and in a browser is writing an application for Chrome OS. It's something we are very, very excited by. And for the record, I'm an avid Google Spreadsheets user, just a disclaimer. So there are a few other use cases people can do. Here's an interesting use case we can demonstrate. So Ken is going to take a picture. In fact, he has one of the new droids, and it has a 5-megapixel camera, so it's pretty cool. So hopefully, we're going to get a good picture out of it. And he's going to take a picture. And let's see what happens if you plug this in your Chrome OS machine. So you can see Chrome OS detects that the camera is a storage device. Now, the phone is a storage device. It can pull the picture right there. So he's clicking on the picture, and here you go. I can see Arlington squarely in the center of the picture. So it turns out there is a video on the phone as well. So let's try and see what happens if you click the video. The video plays right in place in the panel we talked about. So the point here is we really want it to be possible for all these seamless use cases, for all these use cases for users to be seamless. We just want computers to be delightful and work. So we're working very hard to make that possible. One final example like this I want to give is people run into many, many different types of files, right, when they use a computer. They need to be able to use those files. For example, let's go to one of my favorite websites. I go there pretty often. It's irs.gov. And let's poke around and click on a PDF file, right? So what happens if you click on a PDF file? It works. It's instant. It's in the browser, right? So that's the underlying theme of what we are trying to accomplish: speed, simplicity, and security. So I'm going to take a step back from the demo. I'm going to turn it over to Matt Papakippos, who is the engineering director on Chrome OS. And he is going to take a few minutes to walk under the hood. But I would really encourage you to pay attention, because what we are doing is a fundamentally different computing model than what appears on the surface. Thanks.
Hi, so my name is Matt Papakippos. I run the Chrome OS engineering team. So I'm excited to tell you about some of the technology under the hood here. So the first thing to say is we're doing a big open source release today. So as Sundar mentioned, all the code is out in the open now. You can go check it out and build it. In addition, we've done a pretty unusual, interesting thing here in that we've also opened up all of our design documents. So what's the thought process behind this? Where are we going with it? What are the things we're doing next? So we're showing you not only what we've built so far, what the theory was behind it, but the things we're building next and involving the community in that whole process. So what I'll show you today is a sketch of some of those design documents, so you can see some of the technology we've already built and some of the stuff we're still working on, and encourage people to read the docs and get involved. But I'll give you a quick sketch right now. So as Sundar mentioned, speed is a big focus for us here. So we want to make it a very fast, delightful system to use. So what we're going for here is that it feels much more like a television than a computer. We want you to be able to just punch the on button, and it immediately comes on. You log in, you're on the web as quickly as possible. So let me talk about how that works. So one of the first points is all the Chrome OS hardware devices are based on solid-state storage. So what this means is no hard disks. So no disks with the moving parts with iron particles on them. So it's all entirely flash memory-based storage solutions. And that's part of why we can boot so quickly, is because we're actually just reading out of RAM rather than reading out of a spinning magnetic drive. That makes a huge difference. So let me walk through how a conventional operating system boots. I've pictured it here. I won't show you all the details, but there's a firmware process, there's a bootloader, the kernel starts up, system services start, startup applications, browser. The user actually has to click to start the browser typically. No wonder it takes a long time. So to give you a flavor of some of the things that slow it down, when you first punch the power button, your computer still, to this day, spends time going out and probing and looking for a floppy drive. Does anyone actually have a floppy drive in their computer? But your firmware doesn't know that. Your operating system doesn't know that. So they're out there looking for it. And that's symptomatic of one of the reasons that OSs are so slow. So we've really gone in Chrome OS and cut out all of the boot steps that we possibly can. So we've eliminated working to eliminate the bootloader to merge it into the firmware portion, doing a lot of work to optimize the kernel, not start up system services we don't need. As Sundar mentioned, we don't run conventional applications, so we don't need to start up background services for them, et cetera. So we can run a lot faster. And in addition, we auto-start the browser. So as soon as you log in, we start Chrome. We bring up all your application tabs and your tabs from last session, so you're off and running. Another thing we've done on the boot front that's pretty interesting, I think, is we're working on this system that we describe in the design doc called verified boot. And the basic concept here is, exploits happen in the real world, right? There are malware breakouts on any operating system that exists. So the challenge is, once one happens, how do we figure out that it's happened? How do we correct the situation? So as Sundar mentioned, Chrome OS auto-updates itself. So we go out and make sure every day that you're running the correct version of the operating system, that you have all the security patches that we can possibly apply to you. So the essence of the verified boot process is to make sure that every time you boot, we double-check that you're running what you should be running. So the basic concept is that every component of software in Chrome OS, from the firmware to the kernel, to Chrome itself, to the whole root file system, have what's called a cryptographic signature attached to them. And the basic notion is it's as if each one were a document that's signed at the bottom, with the John Hancock saying, yes, this is the right set of bits. So we're using these cryptographic signature keys to make sure when we load the kernel off disk, we check the signature, we make sure that it is the set of bytes that it's supposed to be, and then we transition control to it. So what happens if it goes wrong? So we start to boot a system. We go through the firmware. We go through the kernel. We start Chrome. And we discover that one of the bytes is wrong, right? It fails the cryptographic signature check. So if this happens, there could be multiple reasons. It could be a malware outbreak of some kind. Chrome got hacked. It could be just a random cosmic ray error, right? Sometimes a bit flips in a memory or a hard disk. You get a random error. When that happens, we detect that it's happened. So in this case, the kernel would detect that it's the wrong version of Chrome. Something's wrong. We do the malware detection. And then we go through what we call this recovery procedure, where the system repairs itself. And so from that point, it offers the user a reboot. The user reboots. We re-download the appropriate version of Chrome, reinstall it on the hard disk, and start it up. So we repair the system automatically. And basically what this is doing is re-imaging your computer. The trick here is we've taken what used to be a very painful re-imaging process, right? We've all re-imaged a Mac or a Windows machine. It's incredibly painful. You lose all your data. What we've done here is made it transparent, and we do it in a way where it also saves all your cache data, saves all your system settings, so you don't lose anything in the process. And I'll talk in a bit about how that saving state works. OK, so I was talking a bit about security there. Let me talk a little bit more about security. So here I'll talk about application security. So how do we make sure that applications don't harm your machine? Because this is a primary attack vector for malware, as everyone knows. So the security model of conventional operating systems is something that was developed over 20 years ago, right? The basic application security model for conventional OS is that the applications run with your privileges, right? It's as if the application were you. Right? So if you're allowed to modify a file on the disk, the applications you run on your behalf are also allowed to modify those files on disk. And this creates a bunch of security challenges, because it means that a rogue application or a hacked application could do great damage to your system or to your personal data, or even leak your personal data to other parties. So it's a big deal. It also leads users to have to make some very hard decisions on a conventional operating system. When you install an application, you're taking great risk. You have to make decisions about, do I trust this application? Where did I get it? Is it safe? And these are decisions that are hard for users to make good decisions about. In Chrome OS, we've